Alright guys, today's goal. The learner will understand how to solve trigonometric equations. Alright, see how it says find the general solution? That means there's going to be a whole lot of them. So, just think about this equation like it was 2x plus 4 equals 5. Don't worry about that sign right now. So, if you think about that, you subtract 4. Divide by 2. So I get sine x equals 1/2. You take the inverse sine of 1/2. Okay, so now think on the unit circle. What are the first two positive 1/2s? In radians. So it's pi over 6 and 5 pi over 6. So watch, you would say x equals pi over 6. But when it says general solution, you have to include them all. So you go plus 2 pi n. Because that you can just keep adding 2 pi, 2 pi, 2 pi. And what you do, if I added 2 pi, I'd go back right there. Add another 2 pi. Right there. Right there. Subtract 2 pi. You go right there. So you always have to say plus 2 pi n. And we'll talk about n in a second. And then the other one you would say x equals 5 pi over 6 plus 2 pi n. And then at the end, n is any integer. See, that's key because it has to be a positive or negative whole number, which is what integers are. Okay? So there's the general solution way. So let's take a look at one that's more specific. It says, solve the equation for the interval between 0 and 2 pi. Cosecant squared. Okay? So, again, think about this like 3x squared equals 4. What would you do? Divide by 3. You get cosecant squared x equals 4 over 3. And then, what do you do? Here's the thing, though. We don't know cosecant. Well, we can square root it. Square root it. So you get cosecant x equals plus or minus 2 over the square root of 3. But what is cosecant? Well, it's 1 over sine, which equals plus or minus 2 squared 3. So to get the sine, so then now flip them, because watch, you get sine of x equals plus or minus square root 3 over 2. So then what we have to do is the inverse sine. So you go inverse, because we're looking for that angle of positive or negative square root 3 over 2 equals x. So you have to think on the unit circle. Where are all the areas where sine is square root 3 over 2, positive or negative? So there's 4 answers. Okay? So you have pi over 3, because that's right here, and then 2 pi over 3, and then 4 pi over 3, and 5 pi over 3. So that is every solution in between 0 and 2 pi. So there's the general way, and then there's the specific interval way. Okay? So let's take a look at a couple more. So here's another problem. It says find the general, so we have to think general. Okay? Now, remember what I've been saying. Think about this one like x to the third minus x equals 0. You'd factor out the x, So you'd get x times x squared minus 1 equals 0. And that'd be x times x plus 1, x minus 1 equals 0. And then you set each factor equal to 0 and solve. Well, we have to do that with this. So see how the first step over here, we factored out the x? Well, factor out a sign here. So watch. You get sine x equals sine squared x minus 1. Well, see how over on the right side it was x plus 1, x minus 1? Well, this is, still have the sine x, and then you have sine x plus 1 sine x minus 1 equals 0. Set each of those factors equal to 0. Sine x equals 0. Sine x plus 1 equals 0. Sine x minus 1 equals 0. So you get the inverse sine of 0, the inverse sine of, if you solve that, negative 1, and then the inverse sine of positive 1. Okay? So you have to think, where does sine equal 0? Well, it equals 0 at pi over 2. Nope, that's 1. It equals 0 at 0 and pi. So we have to check those. Where does it equal negative 1 at? Well, we're doing inverse sine, so it's negative pi over 2, because remember, inverse sine is between negative pi over 2, positive pi over 2. And where does it equal 1 at? Pi over 2. Okay? Okay, so we have all these. How far apart are 0 and pi? So watch. Instead of doing 0 plus 2 pi n, you do 0 plus pi n. And aren't these, if we think about the unit circle, negative pi over 2, positive pi over 2, aren't they pi distance away, half the circle? So then you also have pi over 2 plus pi n, where n is any integer. Okay? So there's another example of a general solution. Let's look at another one here. This is solve the equation in the interval from 0 is less than or equal to x and less than or equal to pi. Okay? So see how in this one you have tangent squared and sine and tangent squared? So think about this one as x squared minus yx squared equals 0. So factor out the tangent. And then you'd have 1 minus sine x equals 0. So I have tangent squared x equals 0. 1 minus sine x equals 0. So subtract the 1. Divide by negative 1. So you get sine x equals 1. And then we have tangent, so square root. So now we have to do the inverses. So you do inverse tangent of 0 equals x. Inverse sine of 1 equals x. Now remember, we are restricted between 0 and pi. So between 0 and pi, where does tangent equal 0 at? Well, they equal 0 at 0 and pi. Where does sine equal 1 at? In between 0 and pi? Pi over 2. But, can you do the tangent of pi over 2? No, it's undefined. So that is not it. So it's just 0 and pi. So there's all the different versions, that we're going to see. We see solve the general and solve the interval, okay? So the pi over 2 is one of those extraneous solutions. All right, see you guys tomorrow.